Good morning, it's Coach Jackson, and we're going to be looking at transformations of functions today. The first thing you need to know about transformations of functions, you need to know the parent functions. Uh, there is a constant function, which is number one. That's f of x equals some number. There's no slope. Second function is linear. We also have the absolute value function. Number four is a quadratic. We have the cubic function in number five, and we have a radical or square root function in number six. Those are the main ones we're going to be looking at. And we're going to look at how to transform or move or shape differently these graphs. The first thing we can do to it is we can move it horizontally or we can move it vertically. Okay. To move it vertically, we just add a number at the end or subtract a number at the end. So if we add a number, that's going to move that graph up that many units. If we subtract a number, that's going to move that graph down a certain number of units. Those are the last number in the function. Now, if we want to move it horizontally, left or right, we have to put that number inside the parentheses with the x. And it's sort of the opposite of what you would think as to how it would move. If we subtract a number with the x in parentheses, that moves the graph to the right, that number of units. If we add that number to the x in parentheses, that's going to move it left, that number of units. So notice that left and right here have the opposite of the usual sign. And you should have seen this before. So if we want to graph some of these, and for example, I want to graph x squared plus 3, I'm first going to graph the parent function, which in this case is x squared. If I graph x squared, and I'm going to optimize my board here real quick so I can have some exact graphs. So if I graph x squared, I know that goes through 0, 0. And if I plug in 1, I get 1. If I plug in negative 1, I get 1. If I plug in 2, I get 4. If I plug in negative 2, I get 4. So it looks something like this. That's x squared. Now, this is telling me to move it up 3. So if I take it and I move this graph up 3, all these points are going to move up 3. I take each one of these points that I had drawn or plotted, and I move them up 3. So this one was at 4. I'm going to go up to 7. Over here. So that should be x squared plus 3. Okay. If I look at the next one, it is also x squared. It's x squared. But my 3 is on the inside now, and it's sort of the opposite of the way you would think. I'm going to move this one left 3. So if I move this left 3, every point's going to go left 3. So here's the graph of x plus 3 all squared. Now I've got a vertical and a horizontal transformation in this one. It's still the parent function x squared. So I'll draw my x squared. And this one says I move it right 2 and down 4. So I'm going to take every point here and move it right 2 and down 4. So if I take my 0, 0, and I'll move it right 2 and down 4, there's that point. And then I know I've got one here, one here. So there is my new function, x minus 2 all squared minus 4. Okay. And if you don't remember, this is vertex form. The vertex is given to you. -2. We change the sign on that one. It becomes 2, -4. Reflections. Reflections can happen over the x-axis, the y-axis, or the origin. If you have a negative out in front of the whole function, that reflects it over the x-axis. If you have a negative on the inside of the parentheses in front of the x, that reflects it over the y-axis. So here's an example. My parent function here is the square root of x. So if I plug in some numbers, there's my graph of square root of x. But I got a negative out front. The negative out front is going to flip it over the x. So my true equation is this one. If the x is on the inside, that flips it over the y-axis. So I'm going to flip it this way. Okay. I've still got my square root of x as my parent function. The plus 2 inside is going to move it left 2, and then I'm going to flip it over the x-axis. So if I move it to the left 2, and I flip it over the x-axis, it'll look something like this. Okay. So negative out front flips it over the x, negative inside on the x, inside the parentheses, flips it over the y. For purposes in this class, we always want to do transformations in this order. Do the left and right first, then the reflection, and then the up or down. That way everybody will be on the same page here. So if I was going to graph this one, this is a absolute value parent function. This is the absolute value of x. I want to do horizontal first, so I'm going to move this to the left 4. So if I move this to the left 4, There's the green is the left 4. I want to go down 5. So I'm going to take this one and move it down 5. Okay, 1, 2, 3, 4, 5. And I want to flip it over the y-axis. That's inside, so I want to flip it over the y-axis. So if I flip it over the y-axis, this point's going to come over here. It's going to go this way and this way. So the black one ends up being my absolute value of negative x plus 4 minus 5. Of course, you can type these in the calculator and it'll give you the answer. So I'm not going to spend a lot of time on doing these. You can type them in a calculator and get an answer. Non-rigid transformations. A non-rigid transformation actually changes the shape of the graph. These are formed by multiplying by a positive number. Okay? So if you multiply by a number that's greater than 1, that graph's going to become steeper. If you multiply by a number between 0 and 1, that graph is going to become flatter. Here's an example. And I can show you this better on the calculator. So we'll do that. Bring the calculator up here. So I'm going to graph 3 absolute value of x. And I'm also going to graph just the absolute value of x. The absolute value of x is the red one. The 3 absolute value of x is the blue one. So a number greater than 1 is going to make that graph more steep. It's going to bring the ends of that graph closer together. Well, what if I graph 1/3? One-third absolute value of x. It's going to make it flatter. So the black one is 1/3 absolute value of x. So a number greater than 1 makes it steeper. A number between 0 and 1 is going to compress it down and make it flatter. And that's it for today's lessons. We'll talk to you tomorrow.